Problem number 2, if we draw the triangle, label what we know. There's side A, side B, side C. Let's see, we know side A has a length of 18, side B has a length of 28, and we're also given angle C, which has a measure of 17 degrees. So this is side, angle, side. SAS. For SAS, we use law of cosines again. Now this one's going to be easier than problem number 1 because we're going to start off by looking for the missing side, side C. And the formula is set up in a better way for finding a missing side. We don't have all that algebra to do. So here's our formula. C squared equals A squared plus B squared, so 18 squared plus 28 squared minus 2 times A times B, so 2 times 18 times 28 times cosine of the angle opposite the side we're looking for. This is angle C, which has a measure of 17 degrees. No algebra to do. We're just going to take this entire expression, we're going to plug it into our calculator as one big expression. Resist the temptation to break it up into pieces. You're just likely to introduce a potential order of operations error. So just go ahead and plug the whole thing in all at once. You should get C squared equal to approximately 144 units. We'll take the square root, and we get C equals approximately 12. So now we know side C and we know angle C. So at this point, we're going to stop using the law of cosines, and we're going to find our next missing, we're going to find a missing angle using the law of sines. So we'll just pick one at random. I'll find angle A, I guess going alphabetically. So angle A. And we're going to put, since we're looking for the angle, we're going to put the variable in the numerator, so sine A goes in the numerator. Side A has a length of 18, so sine of A over 18 equals, and now we'll put in the pair that we know, sine of 17 degrees over 12. And then we'll solve, well, we'll actually solve all the way down to A. Multiplying both sides by 18, we get sine of A equals 18 times sine of 17 degrees over 12. Taking the inverse sine of both sides, we get A equals sine inverse of 18 times sine of 17 degrees over 12. And it's important to note that I have not stopped to use my calculator at any point here just yet. I'm only going to use the calculator at the very end. If I use the calculator for intermediate results here, I'm compounding the rounding error that I'm going to get at the end anyway. But if I only do it once at the end, that minimizes the amount of error. So if I plug this into my calculator, I get angle A equals approximately 26 degrees. And again, here I'm rounding to the nearest tenth, but in this case the nearest tenth is a 0, so it's approximately 26 degrees. So now I know two angles. I know angle A is 26 degrees, and I know angle C is 17 degrees. I can find angle B by simple subtraction. 180 degrees minus 26 degrees minus 17 degrees. If you plug that into your calculator, you get B equals approximately 137 degrees. And this triangle is solved.